Type 1 error, type 2 errors both have a probability of occurring that can be calculated. In this class, though, I just want you to know the general notation for a type 1 and type 2 error. A type 1 error is known as alpha, the probability of making a type 1 error. Alpha is the significance level we've been using since we began learning about hypothesis testing. A type 2 error, the notation for that, is beta. Beta is the probability of making a type 2 error. The probability of making a type 2 error is much more complicated to calculate, but it is inversely related to the probability of making a type 1 error. That means if I decrease the probability of making a type 1 error, beta increases. Whereas if I increase the probability of making a type 1 error, beta will decrease. So there's two possible outcomes. Now again, you cannot calculate beta based off of the concepts we're learning in a beginning intro to stats class. The power of the test. The power of the test is the probability the hypothesis test rejects the null when the null is false. This is a good thing. So the power of the test is related to these alphas and betas. It's actually 1 minus beta. So the probability, the power of the test is 1 minus the probability of making a type 2 error. So let's say we decrease the chances of a type 1 error. Our goal is to decrease the chances of a type 1 error. Maybe we look at the consequences. And since alpha is the level of significance, we can pick a smaller alpha, and that will reduce the probability of a type 1 error. However, if you decrease alpha, you increase beta, so you must weigh the potential consequences of each type of error. Now, to decrease the chances of a type 2 error, if you have a sample size set, so if you know how many people you're going to sample, I'm going to sample 100 people. If you increase alpha, beta, the probability of a type 2 error, will decrease. So if you have a sample size set, if you increase alpha, beta will decrease. Now another way to decrease the probability of a type 2 error is if you have a significance level set. So your boss says you have to use an alpha of 0.05. You can reduce beta by taking a larger sample. So if alpha is set 0.05, if you increase your sample size, beta will decrease the probability of making a type 2 error. Example 3. A politician is trying to increase their approval rating, which is currently at 35%. They hire an ad agency to make a positive political ad, and after that ad is shown, they're going to see if the approval rating increased or decreased. So they're going to go and do a poll, see if the approval rating is higher for the politician. Which type of error is worse for the ad agency? How can they reduce this type of error? So before we even start to answer that question, we need to make sure we know what the null and alternative hypothesis is. Since the rating is currently at 35%, our null should be that the approval rating is at 35%. Sorry about that. So HO is that P equals 0.35. If the probability, so if it is still at 35%, that means the ad did not work. The alternative is that they increase the approval rating. That means the ad did work. So let's think about a type 1 error. A type 1 error would mean that we reject the null hypothesis, but we should not have. Our sample suggests that the ad worked. If we're rejecting the null hypothesis, that means we think the ad worked. But it actually did not increase the approval rating in the population. So it's very important that you use that word but when you're explaining the consequences of a type 1 error. A type 2 error means that we failed to reject the null hypothesis, but we should have actually rejected it. That means our sample was inconclusive. It did not give us evidence that the ad worked. So we are failing to reject the null hypothesis. We think the ad did not work. So in which case would this be worse for the ad agency? A type 1, shows that the ad worked. That would be good for the ad agency if the data was showing that the ad worked. A type 2 error says that we do not have strong evidence to support that the ad worked. The politician is going to think that the ad did not work. A type 2 error would be worse for the ad agency. So, what can the ad agency do to avoid a type 2 error? Well, if we look back at the last slide, we know that we can reduce the probability of a type 2 type 2 by either sampling more people, increasing the sample size, or convince the politician that they can use a larger alpha, maybe 10% instead of the more popular 5%. So there's two ways to reduce a type 2 error. Pick a larger alpha, which will reduce beta, or sample more people. Now you should go through and look at the examples in the module and come in with questions. We'll practice this at the beginning of class.